Welcome to Maths with Mrs. V. In this lesson, we're going to be looking at functions and inverses. And as an introduction, I'm just going to explain that inverse functions are actually just functions which have been reflected about the y equals x straight line. So essentially what we can do is we can have a look at a number of different points on the Cartesian plane and see how those would be reflected about this line y equals x. So let's say, for instance, that we have a point here which has an x value of 1 and a y value of 3. So that coordinate we can call 1, 3 as an ordered pair. Now, if we wanted to switch that over the y equals x line or reflect that over, what we would need to do is we would actually need to switch these two x and y values around so that in the new function or the new point would become 3 and 1. So x becomes y and y becomes x. So now our new point will be at x equals 3 and y equals 1. And you can see that those 2 points are reflections of each other across the y equals x line. And we can do that for any point in the Cartesian plane. So if we had to take a point of -2 and -1, so that point would be over here, we can reflect that about the y equals x line, and you can see that it's going to go to -2 on the y-axis and -1 on the x-axis. So this coordinate here was -2, -1, and we can see that it's been switched around. X and y values are switched around to -1 and -2. So when we reflect something across the y equals x line, what we are essentially doing is we are switching around x and y values so that we get our coordinate, which is a reflection of the starting value. So with that in mind, let's have a look at what happens with a few different functions when we actually reflect it over the y equals x line to get an inverse function. So let's start by using the function f of x is equal to 2x plus 1. And I'm going to write that as y is equal to 2x plus 1 so that we can switch around the x and y values. And that's exactly what the first step is. You just need to switch around the x and y values so that you can get the inverse of the original graph. So I'm going to write this as x is equal to 2y plus 1. And then what I'm going to do is I'm going to make y the subject of the formula so that I can have my function in terms of x. So y is going to be equal to x minus 1 over 2. So let's have a look at what these two functions will look like on the Cartesian plane. Let's draw a short table for y equals 2x plus 1 so that we can see the values that we're going to plot. So if I have x and y values, let's choose 0 for x, that's going to give me 1 for y. And if I choose 0 for y so that I can work out the x-intercept, I'll get -1/2. Let's just plot those 2 points on the Cartesian plane so that we can draw that line. So we have our y-intercept, let's call this point here 1, and we have our x-intercept at -1/2. So let's just put that point at -1/2. And then we can join those 2 points up and hopefully we can get a nice straight line through those 2 points. Okay, now let's go and draw the function of y equals x minus 1 over 2. So if we go and make another table, we can have x equal to 0, which is going to get me -1/2. And if we have y equals to 0, we're going to get 1. And we know that this is the case because we've switched around the x and y values. And when we plot that, we're going to have our x-intercept at 1, and our y-intercept is going to be at -1/2. And if we draw a nice straight line through those points, you'll see that you will get a point of intersection with all 3 lines at that point there. And you can see now that the blue line here, which is y equals 2x plus 1, has been reflected over the y equals x line to give you y equals x minus 1 divided by 2. And that is how we get the inverse graph of 2x plus 1. Now let's have a look at a function of a parabola. Let's just use the simple parabola x squared. So I'm going to rewrite that as y equals x squared so that I can invert the x and y values. So first of all, let's sketch that function. So I know that this function is going to sit something like this. And then I can go and switch the x and y values. So I'm going to have x is equal to y squared. And then the next step is to get y to be the subject of the formula. So that's going to be y is equal to the square root of x, but when we square root this, we need to put a plus and minus in front. And this graph is going to look something like this, going through that point of intersection there, through the same point, and then it's going to go back up. So this is now a reflection of the parabola over this y equals x line. So every point on the original parabola is now going to be a reflection point on the other side of the y equals x line. And the last function that we're going to work with is the exponential function. So f of x is equal to, let's do 2 to the power of x. So if I draw this graph, I know that I have a horizontal asymptote along the x-axis. So I can just draw my function in, and I also know that I have a y-intercept at y equals 1. Now to draw the inverse function of an exponential graph, we need to use logs. So the first step is just to make this y equals 2 to the x. And then what we do is we still swap the x and y around. So now we're going to have x is equal to 2 to the power of y. But we want to make y the subject of the formula. And the way that we do that when we have exponents is we can use logs. So the y value will be the subject of the formula. Then we write the word log. And then the base of the log will be the base of the exponent. So we can put that in. And then the argument of the log will be the answer that was originally the x value there. So that's going to be x. And that is going to be my reflection graph across the y equals x line. So what was my y-intercept at y equals 1 is now going to be my x-intercept. And what was my horizontal asymptote along the x-axis is now going to be my vertical asymptote along the y-axis. And so when I draw this graph in, I'm going to draw it with my y-axis as my asymptote and x equals 1 as my x-intercept. And now we have the sketch of the original exponential function and its inverse, which is actually a log function. And to finish off, let's have a look at these 3 examples. So the first one, we're going to rewrite the function as y is equal to x squared minus 4. Then to get the inverse, we're going to switch the x and y values around. And then we're going to make y the subject of the formula. So we can do x plus 4 is equal to y squared. So y is going to be equal to plus or minus the square root of x plus 4. For number 2, we've got y is equal to 2 over x plus 1 minus 1. Switch around the x and y values. And then we can make y the subject of the formula. So we can go x plus 1 is equal to 2 over y plus 1. Then we'll have y plus 1 is equal to 2 over x plus 1, because we can actually just switch these 2 things around as a shortcut. And then we can go and make y equal to 2 over x plus 1 minus 1. And you'll notice that this was actually a hyperbola. And the hyperbola in this case here is actually the same function when we reflect it about the y equals x line. And then the last one is going to be an exponential function. So we can write this as y equals 3 to the power of x plus 2. Switch around the x and y values. And then make y the subject of the formula. So the first thing we need to do is get x minus 2 on the left-hand side. And then we're going to make the log base is 3 and the log argument will be x minus 2. So we can write y is equal to the log of base 3. And then when we have more than one term, we put brackets around it with our argument inside. If you found this video helpful, please consider liking and subscribing so I can make more videos.